in this example, in the next couple of examples, we're going to look at exponential functions that have the base e. E is a very important number, stands for Euler's number. It's approximately equal to 2.718. It actually goes on and on forever. It's an irrational number, kind of like pi. Now we're going to use the fact that e lies between the values of 2 and 3 to sketch out a graph of e to the x. So we know what the graphs of 2 to the x and 3 to the x looks like, and we're just going to sort of plot each of those somewhat, roughly, and then use those graphs to guide our graph of e to the x. So I'll do 2 to the x first. We know that 2 to the 0 is 1. At -1, 2 to the -1 is a half. Right, and 2 to the -2 is a quarter. And you can sort of go back to what we did a couple examples ago when we sketched this out. If you want to sort of see where we calculated out those y coordinates. 2 to the first is 2. 2 squared is 4. And 2 cubed is 8. So here's a graph of 2 to the x. Next we'll do 3 to the x. Do that one in blue. Three to the -1 is a third. 3 to the 0 is 1. 3 to the first is 3, and 3 squared is 9. And so now we're going to use these graphs to get a graph of e to the x. Since e lies between 2 and 3, I know that the graph of e to the x will lie between the graphs of 2 to the x and 3 to the x. And not only that, since e is a little bit closer to 3 than it is to 2, we should expect that that graph will lie a little bit closer to the graph of 3 to the x than it does to 2 to the x. And so that's a pretty good kind of sketch of e to the x without really having to plot a single point. I mean, the only point I made absolutely sure that e to the x went through is the point 0, 1 that all of these exponential functions go through.